This is my second video on grade 11 chemistry topics, some basic concepts of chemistry. And today we'll be doing question 1.7 to 1.12. For first 6 questions for the same chapter, you can refer my previous video. So the very first question, 1.7, how much copper can be obtained from 100 grams of copper sulfate? So to solve this problem, we need to understand what is the relationship between copper sulfate and copper. And from one formula unit of copper sulfate, we can see that we are having one copper atom. So 1 mole of copper sulfate will give you 1 mole of copper atom. And 1 mole of copper atom means what? It is equal to the atomic mass or the molar mass of copper, that is 63.5 grams per mole. And for copper sulfate, 1 mole will be equal to the molar mass of copper sulfate. So molar mass of copper sulfate is calculated with the help of sum of atomic masses of all the atoms which are present in the molecule. And it is calculated as 159.5 grams per mole. So in this table, we have given atomic masses of all the elements which are present in copper sulfate. Now, we'll apply the idea as discussed here. So from 159.5 gram of copper sulfate, we'll get 63.5 grams of copper metal. Therefore, from 100 grams of copper sulfate that is given in the question, so you will get 63.5 divided by 159 multiplied by 100 grams of copper metal. So it is calculated as 39.81 grams of copper. So this is the answer. Amount of copper obtained will be 39.81 grams. Now come to the second question, 1.8. Determine the molecular formula of an oxide of iron in which mass percent of iron and oxygen are 69.9 and 30.1 respectively. And they have given you molar mass of oxide. So first we need to understand that what are the basic steps to find out the empirical formula. And for the same question, you can refer my question 1.3 from the previous video. So here again I am repeating briefly how to find out empirical formula. So in the question, they have given you mass percent of both the elements which are present in the oxide. So this is your mass percent which is given to you. This mass percent we will convert in mass in gram by supposing that we have 100 gram of oxide. And this mass in gram is used with the help of atomic mass to calculate moles of element. And we know that number of moles is equal to mass divided by the atomic mass or molar mass. So we will calculate number of moles of iron as well as oxygen, and it is calculated as 1.25 for iron and 1.88 for oxygen. Now we'll find out the simplest molar ratio. So to calculate molar ratio, we will divide each value with the smaller value obtained. Therefore, we'll get molar ratio for iron as 1 and molar ratio for oxygen as 1.5. Now, issue is we cannot keep molar ratio as a fractional number. So we'll multiply it with a specific coefficient to get the whole number value of molar ratio. So we'll get here two numbers, 2 for iron and 3 for oxygen. So these two numbers will give you the empirical formula. So the second step is to write down the empirical formula. Empirical formula of oxide is Fe2O3. Now next step is from the empirical formula that you have determined with the help of these steps, you will find out the empirical formula mass. So it will be calculated just like we calculate the molar mass. So it will be done with the help of the atomic masses. So we have mentioned in the table atomic masses of iron and oxygen. So empirical formula mass of oxide is calculated. Now next step is how to relate empirical formula with the molecular formula. So the idea is molecular formula is equal to the empirical formula with a factor that is n. Okay, so n is a number, and how to find out a number? This number n is equal to molar mass or molecular formula mass divided by empirical formula mass. So molar mass is given to you in the question. Have a look here. They have given you the molar mass of oxide. So most of the time in the questions where we have to find out the molecular formula, they will provide you the molar mass or some information related to the molar mass. So the molar mass will be divided by empirical formula mass, and this empirical formula mass we have calculated with the help of empirical formula. So this is the given value and this is the calculated value, and you will get value of N is 1. So it means what? It means molar mass and empirical formula mass are same. Therefore, molecular formula is same as empirical formula, that is Fe2O3. So the molecular formula of oxide will be Fe2O3, and this is your ferric oxide. Okay. Next question, 1.9. Calculate atomic mass or average atomic mass of chlorine using following data. So in the table they have given you two isotopes of chlorine, chlorine 35 and 37. So here 35 and 37 are the mass number of isotopes, and in this column they have given you percent natural abundance and they have given you molar masses of both the isotopes. So we have to find out the average atomic mass. You know that those elements which exist in the form of their isotope, so the mass number which is mentioned in the periodic table is basically the average atomic mass number, not the exact value of a specific isotope. Okay, so average atomic mass is calculated with the help of this formula. Here what we have done sum of product of fractional abundance of isotope and the molar mass of the isotope. So sum of product of fractional abundance and the molar mass means what? Fractional abundance of first isotope and the molar mass of first isotope plus fractional abundance of second and molar mass of second, and so on. Here fractional abundance or fractional natural abundance is not given in the question. They have given you percentage or percent natural abundance. So this percent natural abundance is converted to fractional one by dividing by 100. So percent natural abundance divided by 100, you will get the fractional one. And the mass numbers are given in the question. And what is N? N is the number of isotope. Like in this case, they have given you two isotopes. So in our case here, a value of N is 2. So what we will do, first we will find out the fractional abundance, as it is not given in the question. So fractional abundance of chlorine 35 will be this and chlorine 37 will be this after dividing the given value by 100. Now, average atomic mass of chlorine is calculated as fractional abundance of first isotope multiplied by the mass or molar mass of first isotope plus fractional abundance of second isotope multiplied by the molar mass of the second isotope. So, we will be getting these values, and therefore, the average atomic mass of chlorine will be 35.4527 unit or unified mass. Now, in your periodic table, this value is approximately written as 35.5 units. And this is why we have written a fractional value of atomic mass in your periodic table or mass number in periodic table, because it is basically the average atomic mass of different isotopes. So this is all about this question. Next is 1.10. In 3 moles of ethane, that is C2H6, calculate the following: number of moles of carbon atom, number of moles of hydrogen atom, and number of molecules of ethane. Be very specific, number of molecules. So when you are reading a question, be very smart to read the content, and it will be better when you are solving anything in your exam, in your question paper, you mark the important terms which either are given or you are supposed to calculate. So what kids will do mistake here, they will calculate moles in all 3 cases, but in the last part they have given you molecules. So be very clear about what they are asking. Okay, now before solving this, let's have a clear idea that how to find out how many atoms of different type are there in the given molecule. So ethane is C2H6. So in one molecule we are having 2 carbon atom and 6 hydrogen atom. Therefore, from 1 mole of ethane we will get 2 moles of carbon atom and 6 moles of hydrogen atom. This is the basic idea, and this we will apply to solve these 3 parts given to you. So the very first one, 1 mole of ethane contains, as we did here, 2 moles of carbon atom. Therefore 3 moles of ethane we will multiply 2 by 3, therefore 6 moles of carbon atom. So first answer is, you will get, for the first part, you will get 6 moles of carbon atom. Second, 1 mole of ethane contains 6 moles of hydrogen atom, as we did here. So 3 moles of ethane will have, therefore again 6 into 3, you will get 18 moles of hydrogen atom. So second answer is, for the second part, you will get 18 moles of hydrogen atom. And to solve the third one, we should apply this concept, that is the idea for Avogadro's number. 1 mole of any substance is equal to the Avogadro's number of particle, that is 6.022 into 10 raised to the power 23 particles. What is the meaning of 23 particles? If we are doing for an element, these particles will be atom. If we are doing for a compound or a molecule, these particles will be molecules. And if we are doing for suppose electron, so these particles will be electron. Okay. So now for the third part, 1 mole of ethane contains what? Avogadro's number of molecules of ethane. You know that 1 mole is equal to Avogadro's number of particles. Therefore, 1 mole of ethane will be having how many ethane molecule? Avogadro's number of ethane molecules. Therefore, 3 moles of ethane will have, obviously it will be multiple of this number, that is Avogadro's number. That is 3 times of this number. So we'll get value 18.06 into 10 raised to the power 23 molecules of ethane. This value you can write like this also, 1.806 into 10 raised to the power 24 molecules. Both answers will be correct. Okay, because this is we have written as such after multiplication. We have not written in the standard form. So you can convert answer in standard form, or you can write like this also. Both will be correct answer. Next question, what is the concentration of sugar in moles per liter if its 20 grams are dissolved in enough water to make a final volume up to 2 liters? Okay, so what is given to you? They have given you a sugar, that is C12H22O11, and what mass is given? 20 gram of the sugar is given to you, and final volume we have to make 2 liters. And we have to find out concentration in moles per liter. So concentration in moles per liter means what? We have to calculate molarity of the solution, and molarity is equal to number of moles of solute divided by volume of solution in liters. Now for calculating molarity or concentration in moles per liter, we need number of moles of solute, which is not given to you. They have given you mass but not moles. So we'll calculate number of moles of solute, which is equal to mass divided by molar mass. Now mass is given to you in the question. We need molar mass. So what we'll do, we'll calculate molar mass of the sugar. So when you're solving any numerical, few information is directly applied, and rest of the information you have to modify a little before applying in the formula. So don't try to apply the given information directly in the formula as such as given in the question. Okay, like here molar mass is not given, okay, but we can calculate easily because atomic masses of these 3 elements are what? Everyone know that what are the atomic masses. They are simple elements. So first we'll calculate the molar mass of the sugar. Now atomic mass of carbon is or the mass number is for carbon is 12, mass number for hydrogen is 1, and for oxygen it is 16. Okay, so these values will apply. So in the molecule, we are having how many carbon atoms? We are having 12 carbon atom. 12 carbon atom multiplied by the mass number, that is also 12, or atomic mass, that is also 12. So 12 into 12 for carbon. Next, we are having 22 hydrogen atoms. So 22 into 1 is the mass number or atomic mass. And for oxygen, it is 11 because we are having 11 oxygen atom into 16 because atomic mass is 16. So the molar mass of the given sugar will be 342 grams per mole. Okay, so next, number of one thing, don't get confused that we are not applying any unit here and we are mentioning unit here. Your atomic masses or the molecular masses, they are having unit, unified mass, and they are basically numbers. But when we are writing answer as molar mass, we have to put a unit grams per mole. Why? Because molar mass is basically mass in grams for 1 mole of any substance. Fine. So molar mass is nothing but atomic mass or molecular mass expressed in grams per mole. So number of moles of the given sugar will be calculated as mass, which is given to you, and the molar mass, which we have calculated. So these are the number of moles. So lastly, we'll calculate the molarity of the given solution, and number of moles, which we have calculated here, divided by 2 liters. This is given to you in the question. So molarity of the given solution will be 0.0293 moles per liter, or concentration will be 0.0293 moles per liter. So this is your answer. Next question, 1.12. If density of methanol is 0.793 kilograms per liter, what is its volume needed for making 2.5 liters of its 0.25 molar solution? Okay, so again, as I told you in the previous question, focus on the given information and try to manipulate the information, or what you say, process the given information so as to get the answer. So in your question, they have given you a solution with density. So this is our given solution, this one, and here density is given to you. Rest of the information for any solution, what we need? Molarity. Molarity we do not know, and volume of this solution required to prepare a new solution is also not known. Okay, so we have to find out molarity of this solution, and then what volume of this solution you will require to prepare a new solution after dilution. So given solution is basically acting as a stock solution that is there in your lab, and from the stock solution you will prepare a dilute solution of required concentration. So here we have to prepare a new solution of given molarity and volume. So when we are doing any numerical on concept of concentration, especially molarity or molality, we need number of moles, and for that we need molar mass. So if it is given in the question, then it's fine. If it is not given, you have to calculate. The very first hand information that you will need will be the molar mass. So let's calculate molar mass of methanol. Methanol is CH3OH. Okay, it is having 1 carbon atom, 3 plus 1, 4 hydrogen atoms, and 1 oxygen atom. So molar mass will be, the mass number for carbon is 12. So therefore 1 carbon atom, 12 as such. 4 hydrogen, therefore 4 into 1, mass number is 1. And for oxygen, the atomic mass is 16. So it is calculated as 32 grams per mole. Now this molar mass, we will express here in kilograms per mole. Usually we utilize in grams per mole, but in this particular numerical, we will convert this value in kilograms per mole. And for that, this value we have to divide by 1000. Okay, to convert grams in kilogram. Why we are doing this? Point is, we will be using this value of molar mass later on in the question, and the units for density is given to you as kilograms per liter. So we want to keep the same unit as kilogram there in the density. Same we will put here. it will be clear later on when we will do the calculation. So you know that concentration in terms of molarity is equal to number of moles divided by volume in liter, and this number of moles we have written here in the form of mass divided by molar mass. Okay, so the first equation will give you molarity in terms of number of moles divided by a volume of solution in liters, and since we are calculating for the first solution, so therefore I have written here V1. Now density, all of us know density is equal to mass divided by volume. So the second information equation is giving you density. So if you compare equation number 1 and equation number 2, we will get such type of calculation or arrangement, and from this on simplification we'll get molarity is equal to density over molar mass. Okay, so this is a new formula that we are going to use, that molarity is can be calculated as density divided by molar mass. So density is given to you in the question and molar mass you have calculated in kilograms per mole. Now you must have understood why I have converted unit for molar mass from grams per mole to kilograms per mole. So the molarity will be calculated from this formula, and we will get molarity of the first solution, that is your M1. Okay, now for first solution, volume is also required. What volume of this is needed to make a dilute solution? So here we will apply the idea that number of moles of solute before mixing or before dilution will always be equal to the number of moles of solute after mixing, because we are doing it in the light of law of conservation of mass. Okay, so therefore total number of moles before dilution should be equal to total number of moles after dilution for the given solute. Therefore M1 V1 is equal to M2 V2. So V1 is calculated from here, because M1 M2 is given to you, M2 V2 is given to you, and M1 you have calculated here. Therefore volume needed is 0.02522 liters or 25.22 ml. Okay, so 25.22 ml of first solution will be having the same number of moles of methanol as are there in 2.5 liter of the new solution. This is what law of conservation of mass. So from here we will take your 25.22 ml and we will dilute it with a solvent, and then we will get the new solution. So this was the last question. I hope it is clear. This is all for today.
Thanks for watching our video. Don't forget to like and subscribe, as we will be posting more videos on this topic soon.